Today we're going to talk about logarithms. Recall that a one-to-one function has an inverse function. In particular, the exponential function we talked about in previous video is one-to-one and hence has an inverse function. This inverse function is so important that it is given a name, the logarithmic function. The logarithmic function to the base a, where a is greater than 0 and a does not equal 1, is denoted by y equals log base a of x. We read this as y is the logarithm to the base a of x. And it's defined by y equals log base a of x if and only if. And if with a double F represents if and only if. X equals a to the y. As this definition illustrates, a logarithm is a name for a certain exponent, so that log base a of x represents the exponent to which a must be raised to obtain x. So let's relate logarithms to exponents. We're going to convert logarithms to exponents. We have an example 1 here. We have 4 equals log base 3 of 81. So we're going to use the definition. So our base, we have a is 3. Our x is 81 and our y is 4. So we're going to convert this logarithm to an exponent. So we're going to have our x, which is 81, is going to equal our base, which is 3, raised to our y, which is 4. And we see that 81 equals 3 to the 4th. Example 2, we're going to convert this logarithm to an exponent. We have our a is 5, our x equals 1/5, our y equals -1. And so we're going to have our x, which is 1/5, equals our base 5 raised to the -1. And 1/5 is 5 to the -1. Example 3, we are going to convert this logarithm to an exponent form. So we're going to have our base, which is a. We don't have a number on this one. And our x is 4 and our y is 5. So we're going to have our x, which is 4, equals our base to the y power, which is 5. And so that is what this logarithm looks like in exponential form. Example 4, we're going to convert this exponential form to a logarithm. So we're going to go backwards. So we're going to take the fact from our definition. So we got our base is 1.2, our y is 3, and our x is m. So this is going to turn out to be, we're going to have our y equals, so 3 equals our log of base 1.2 of our x, which is m. And now example 5, we're going to see that we can use this conversion between logarithms and exponents and vice versa to solve logarithms. To evaluate log base 2 of 16, we need to think 2 raised to what power yields 16. So we're going to rewrite it to 2, our base, raised to some power y equals 16. So this is changing it into our exponential form. So 2 to what power gives us 16? 2 to the 4th power equals 16. So we're going to have our y equals 4. So log base 2 of 16 is 4. In the next video, you will learn more about logarithmic equations and functions.